Hello students, in this video we will be discussing about the data structure types. Now data structures can be in-memory data structures or they can be secondary storage data structures, but the focus of all the videos in this particular channel will be on the in-memory data structures. So we will be discussing the linear linear data structures and the non-linear data structures. Linear data structures are those which are sequenced. That means one element follows the other. There is an absolute first element, second element, third element, and so on. Now the basic data structures, they include, under this we have basic and derived. Basic means which are the building blocks for other data structures, and derived data structures are built from the basic data structures. So the basic data structures, first is array, which you have done in C language. Arrays are contiguous allocations in the memory, for similar data type. So it is something like we will be discussing all of these in detail in the subsequent slides. So first, for now, we understand that array is a continuous allocation in the memory. Then we have linked list. Linked list is which is not a continuous allocation, but it is a linked memory, or it is scattered throughout the memory, and we use pointers for linking those pieces of memory. Then we have derived data structures. In this we have stacks and queues. Stacks can be either implemented using array or linked list. Similarly, queues can be implemented using the array or the linked list. Then we have the non-linear data structures. Non-linear data structures are those in which the first element, second element cannot be established. There is no sequencing among the elements, and they can be more than one possible ways of traversing this data type. So we have trees. Trees are the data structures in which we have hierarchical representation, and then we have graphs which have a network representation. So let us do each of these data structures in detail. Now coming to the details, we have the okay, here we have explained what are linear and non-linear. So linear data structures are those which have a sequential order. We can clearly determine the first and second and so on. Like in an array of 10 elements, it is clear that the element at the index 0 is the first element, index 1 is the second element, and so on. These are flat and single dimensional in nature. Then we have non-linear data structures which are non-sequential in order and can be arranged in a number of manner. Like tree is hierarchical in nature, graph is a peer-to-peer network. Moving on to the arrays. Now array is a collection of homogeneous elements or similar elements. It is generally used when we allocate a bulk of memory by the same name, single variable name, and then with that variable name we attach the subscript value which refers to which element under that name we are referring to. So all the elements, they have the same name and we refer to the individual element using the index number. So for example, you want to declare an array of size 5, then in C language we will write int arr, in the square brackets we'll write 5 is equal to the elements. Now assigning these values is completely optional. So since the size is 5, so there are 5 elements, but the counting will begin from 0. So 25 is element 0, 35 is element 1, 45 is element 2, 55 is element 3, and 65 is element 4. As we can see here, we have an array 0, we have element 25. Suppose the starting address or the memory location allocated is 240. Now since it is of type integer, the memory address of each of the elements in the array is separated by a factor of 2 in a normal turbo C environment. So the first element array 0 is at location 240, array 1 is at location 242, so array 2 is at location 244, and so on. In each of the elements their specific values are stored. Now these addresses, they are used to refer to each element in the array. Then the linked list. Linked list is a linked representation. in which we have, say, this slot in which we have the data part and the next part. Next part will point to that memory location where that element is placed. Suppose we have a memory allocation at location 242 and element A is placed in this. Now next will point to, say, location 340 where B is placed. Now this pointer next will point to the location, say, 500 where C is placed. So these are separately scattered all over the memory and they are linked by the pointer. So this is a linked list. So for example, we have elements 1, 2, 3, 4 and 6. Now we have first element, it has a pointer which points to the second element, which has a pointer to the third element, pointer to fourth, pointer to next element, and the last element will point to null, indicating that the linked list has ended. So for storing this type of a data structure, we use a structure under C, and in that we have an information part and we have a next pointer which is of same type as the node itself. Then we have stacks. Stacks are last in first out arrangements which are implemented using arrays or linked lists, and it is similar to a stack of coins in which the last coin can be removed only when the previous all coins have been removed. We will be doing each of these data structures in detail in the subsequent videos. Then we have a queue. Queue is the set of elements in a particular order which follows the first in first out. Like in a cinema hall, people are standing in front of it in a queue, so the people will be removed from the beginning and the new elements or new people will be added at the end. So it is just the reverse of the stack. In this stack, the element will be removed from the end. This is the end and this is the beginning. And in the queue, the element will be removed from the beginning and added from the end. Then we have a tree. Tree is a hierarchical data structure. For example, you have a file structure in C or Windows, in Unix or Windows. So in this we have directory 1 which has 2 subdirectories under it, then multiple subdirectories under each of them. So this is a hierarchical organization. Then we have graphs. Graphs, they consist of two parts, vertices and edges, and these the various vertices, they are linked using the edges. So with this we come to the end of the types of data structures which we will be covering in the subsequent videos. Thank you.